Aloha everybody, this is Gigi from Kauai Community College. In this video, we will be talking about onion problems. Onion problems. Yes, you heard that right. Onion problems. Let's go see what an onion problem is. So here we have onion versus not an onion, or I would call that a stinky rose. Onion, stinky rose. Pause the video at each set and ponder what the differences are and the structure of each one of these equations. Okay? Again, onion, stinky rose. What's the difference? Onion, stinky rose. So what's an onion? Onions have layers. So your job is to undo the layers. Where a stinky rose, you see the unknown x happens everywhere here, and it's more complicated to solve, right? It's not just a process of like an onion where you have layers of operations and your job is just to undo the layers from outside to inside until you get to the variable x. Okay, so what do I mean by that? Here, the outermost layer is plus 2, so to undo plus 2, I would subtract 2 to both sides. So I will have x minus 1 on the square on the left-hand side is equal to 9. And then the outermost layer now for this newly obtained onion is square. So how do we undo square? Square root both sides. So what square will give me 9? That's the question here. X minus 1 will have to be a positive 3 or a negative 3. Both of which square up will be 9. So then the next layer in this onion is to undo subtraction. And to undo subtract 1, I would have to add 1 to both sides, and x will equal to positive 3 plus 1 is 4, or negative 3 plus 1 is negative 2. And that is how we deal with onions. Onions have layers, right? So we have to just undo the layers until you get to the core, which is the unknown x. Okay, now you have seen this type of stinky rose before, where you have to go ahead and get 0 on one side and everything else on the other. So it is of the form ax squared plus bx plus c equal to 0, and then you will have to either factor to solve, or you will use the quadratic formula to solve, right? But that's not what I'm going to proceed in this video, because our focus here is on onions. Okay, so onions have layers, and our job is to peel off the layers from the outermost to the innermost to get the core, which is x, by itself. Okay, again, onion. And how do we know? The core x is right here, and all we got to do is just undo the layers around it. Whereas this here has is a stinky rose because it has 2 different square roots, one on this side, one on the other, and then it has plus 2. It is it sort of had clumps to it rather than just layers. Okay, so again, onion, we will go ahead and undo the outermost layer. In this case, the outermost layer is plus 2, so we will go ahead and subtract 2 to both sides, right? And once you do so many of these, you really don't need to write down every single step. I mean, it's okay for you to do that. But I think in this case, sometimes the less you write, the cleaner the solution will look. Okay, but go ahead and write -2 to both sides if you need to. Here, when I subtract 2 to both sides, I will have 3x plus 7 is equal to 8 minus 2 is 6. Now, the outermost layer in this case is square root. So how do we undo square root? We will square both sides of the equation to undo square root, right? So square under square root. What I have is just the input, which is 3x plus 7 is equal to 6 squared is 36. Here I have a linear onion. The outermost layer is plus 7, so I'm going to go ahead and subtract 7 to both sides. So 3x is equal to 36 minus 7 is 29. So then I will go ahead and undo the last layer to get x by itself. The last layer is multiplication, so I'm going to go ahead and divide to undo multiplying. So that would be 29 over 3. And that would be your solution. But don't forget to plug it back in and check, right? So if you plug it 29 over 3 in for x, you will have multiplying that by 3. That will give me 29. 29 plus 7 is 36. Square root of 36 is 6. 6 plus 2 is 8. And this is a perfectly fine answer. Okay, again, stinky rows here, we will deal with that later in the course because the strategies for solving these stinky roses are different in each scenario. Whereas onions have layers, and you just have to undo the layers. Onion, sticky rose. So here, let's go and undo the outermost layer, which is the plus 2, right? So to undo plus 2, you'll have to minus 2 to both sides, and you will get 3 divided by 5 minus x is equal to 6 minus 2 is 4. And I just said divided by, so to undo division, I would have to multiply both sides by the same thing so that I can undo the division. What am I going to multiply by? I'm going to multiply by 5 minus x because that's the thing that was divided by. So multiply by 5 minus x to both sides. Multiplication under division, I have 3 left is equal to here. You can keep it and divide by 4, or you can distribute. I'm going to go ahead and distribute. I will have 20 minus 4x. That leaves me with a linear onion, right? So now go ahead and subtract 20 to both sides. I will have negative 17 is equal to negative 4x. And then multiplication is being undone by division. So divide both sides by negative 4. X is negative divided by negative is a positive, and that would be 17 over 4. And that is how we solve an onion problem. Again, these stinky rows here, onion, stinky rows. Stinky rows, we will deal with that later in the course. All right, when looking for the x-intercepts of a function, remember, x-intercept is where the graph crosses the x-axis. Where the graph crosses the x-axis is when y is equal to 0. So what do you have when you say, well, what if y is 0? What do you have here? And you have it. You have an onion problem, right? You have an onion problem to solve. So here we go. In order to solve for x, again, onions have layers. So undo the layers. Minus 2 to both sides. Negative 2 is equal to negative 4 times cube root of 1 minus 2x. And then divide both sides by negative 4. I will have 1/2 is equal to cube root of 1 minus 2x. How do we undo cube root? Cube it. Cube both sides. So I will have 1/8 is equal to cube undoes cube root. 1 minus 2x is what I have left, just the input there. And then what am I going to do next? Undoing the outermost layer, which is the plus 1 that's hanging there. So undo plus 1 by minus 1. Minus 1 plus 1/8 is negative 7/8 is equal to negative 2 times x. To undo negative 2 times x, you would have to divide by negative 2. And since I have a fraction on the left-hand side, it might be simpler to go ahead and think of it as multiplying by negative 1/2, right? Dividing by negative 2 is the same as multiplying by negative 1/2. So x will equal to negative times a negative is a positive, and I will have 7/16 as my solution. So again, all right, now that you solve for x, the answer really is find the x-intercept, right? So your x-intercept in this case is not just x equals to 7/16, but the x-intercept is a point on the graph, so it would be 7/16, 0, and that is your x-intercept. Onion problem, undoing the layers, right? Undo the layers. Undo your layers when you have onions. I hope you do like the onions because that makes your life a lot easier. Now, normally in real life, onions make you cry. Here, onions are great because you know all you got to do is just undoing layers.